All right, so we're going to perform our lab. We have three different frogs. We have one frog that has no extra staples added to him. We have another frog that we've added some extra mass to him. He has 26 extra staples on him. Yes, 26. And then we have one who has 46 extra staples added onto him. There we go. So we're going to test and write down our information. So we have frog 1, which has the so no extra staples. The frog 2 has 26 extra staples, and then we have the frog 3 who has 46 extra staples. Okay, so on that chart that you have in the lab, so the chart that's on the lab slideshow, you can just copy that, or you can print it out if you want. But I mean, just rewrite it. Here you can just make something like this. The distance 1, distance 2, distance 3 are the three different frogs. So there they are with the no extra, 26 extra, and then 46 extra staples. So this is what I've added to them. All right, so we've done that because we want to test, we're testing a variable, and the variable is the amount of mass. So the question that we would be asking from this would be, does mass affect the amount of motion or distance traveled if you apply the same amount of force? Now, I'm going to try to give as much, try to give the same amount of force in each situation. That is, I would be compressing them down at the same length in each one. So here we go. I have the wonderful little frog here, and he is going to travel. We'll see how far. Well, that didn't quite work out. Here we go. Let's see. We're all watching you, buddy. All right, he went 13 centimeters. 13 centimeters. So distance 1 is 13 centimeters. All right, let's keep going. All right, that time he went 19 and a half centimeters. So 19 and 5/10 centimeters. Okay, so 13 centimeters and then 19 and a half centimeters. All right, so that's 2. Let's do 3. Oh, that didn't work. Let's not count that one. Come on, buddy. Everybody's watching you. You need to live up to these expectations, man. All right, and this one, distance of 18. So 18 centimeters. Okay. Now let's go with the second frog, 26. Okay, so that is 12 and a half. So 12.5 centimeters. 12 and 5/10 centimeters. Yeah. 16 and a half. 16 and a half centimeters. And let's do this one more time. Oh, there we go. It is 14 centimeters. All right, so noticeably some noticeable difference here. See, the first frog had no extra mass, and so he was able to go a little bit further compared to the other one, right? Okay, well, let's keep going. Let's go to the third frog who has 46. He's coming here with a disadvantage. Okay, whoa, not much of a disadvantage. That's about 16 centimeters. Okay, let's keep going. That one didn't count. All right, we'll count that one. That one had some spring there. That was about 9 centimeters. And about 12. Okay, 12 centimeters. Okay, so if you're giving the same amount of force to each one of these, and it's pretty consistent because they're both we're compressing them down, and that is storing up energy in them, right? So when they're compressed down, they have potential energy. When it's released, that would be its kinetic energy. But they all are given the same amount of potential energy, right? They all have the same potential. However, the only difference is that we've added mass. We've added mass to the other two. So this one has 26 extra staples, which is about 26 extra grams of mass. And this one has 46 staples, which is about 46 extra grams of mass. It's not going to be exact. But so you can see that especially looking here, that it seems, and if we could continue to collect data here, but the data seems to be pointing out that, I mean, if we added all these up, you would see that, you know, oh, the more mass you add to it, while still applying the same force, though, the same amount of force applied to different masses will be less, will travel less. Those masses will travel less when they are given more mass. So that can be a takeaway. So the more mass that's added, even though they're also given the same amount of mass, I mean, even though they're given the same amount of force, they still have the same amount of energy stored up. When that energy is released, some of it goes into trying to move that mass. If they have extra mass added onto them, they're not traveling as far. So that's an interesting takeaway. All right, there we go.